ignition of the RS-68A main engine, and we have liftoff of the United Launch Alliance Delta IV Heavy rocket.
Execute, and then indication of spacecraft separation.
At Space Launch Complex 6, a Delta IV Heavy rocket is fueled and ready to launch the NROL-82 mission for the National Reconnaissance Office. Good afternoon and welcome to Vandenberg Air Force Base in California. I'm Caroline Kirk, a systems engineer with ULA. Liftoff is currently planned for 1:47 p.m. Pacific, and the launch team is not working any issues at this time. Approximately 15 minutes ago, the launch count entered a planned hold. We have 2 planned holds in today's 9.5-hour launch count. These planned holds give our team additional time to resolve any issues that come up prior to entering the terminal count. At the request of our customer, today's live mission coverage will conclude following payload fairing jettison, scheduled to occur just over 6 minutes after liftoff. In addition to watching our webcast, you can follow live mission progress at ulalaunch.com. First Lieutenant Max Rush, the 30th Space Wing's weather officer, recently briefed the weather conditions here at Vandenberg Air Force Base. Here's what we're seeing. The probability of violating launch constraints is 40%, the ground winds are 10 to 15 knots out of the northwest, and the temperature is 55 degrees Fahrenheit. So, the weather is within the launch commit criteria and looks favorable for our planned T0 at 1:47 p.m. Pacific. Today's flight will head south away from our launch pad here at Vandenberg Air Force Base. Let's take a look at what else we can expect to see.
5, 4, 3, 2, 1, and liftoff of the United Launch Alliance Delta IV Heavy rocket.
At T-minus 14 seconds, the launch table HBOs ignite to burn off excess hydrogen injected into the flame duct. At T-minus 7 seconds, the starboard Delta IV ROFI lights, igniting its RS-68A engine. 2 seconds later, the center and port RS-68A engines ignite, generating more than 2.1 million pounds of total thrust to lift the rocket off the pad. This staggered engine start mitigates the fireball created by the hydrogen-burning Delta IV Heavy. Shortly after liftoff, Delta IV begins a pitchover to attain the proper flight path while minimizing the pressure the vehicle experiences during flight. The Delta IV reaches Mach 1, the speed of sound, at 1 minute 21 seconds. At 3 minutes 56 seconds, the port and starboard booster engines shut down. 2 seconds later, the port and starboard boosters are jettisoned to shed their weight. The center booster engine then throttles to full power to maximize performance against gravity losses. Approaching main engine cutoff, Delta IV is burning propellant at a rate of 1,945 pounds, or 882 kilograms per second, traveling at more than 12,725 miles, or 20,479 kilometers per hour, and located 130 miles, or 209 kilometers in altitude, and 350 miles, or 563 kilometers downrange. At 5 minutes 37 seconds, propellant levels deplete, and the main engine shuts down. 7 seconds later, the Delta IV separation system activates to release the first stage. The vehicle now weighs approximately 7% of what it did at liftoff. At 5 minutes 57 seconds, the Delta Cryogenic Second Stage, or DCSS main engine ignites to carry the payload to orbit. During ascent, NROL-82 is protected inside a 5-meter diameter payload fairing. At approximately 6 minutes 7 seconds, the payload fairing is jettisoned. Delta IV continues its national security mission following payload fairing jettison.
After today's liftoff, our viewers watching from Southern California may be able to see the Delta IV Heavy in flight. And, as you can see from this graphic, those of you located in Los Angeles and the surrounding areas might even see port and starboard booster separation at approximately L plus 4 minutes. To get a closer look at this graphic, check out @ULA Launch on Facebook, Twitter, and Instagram. ULA is using the Delta IV Heavy configuration to launch the NROL-82 mission. This is the 13th Delta IV Heavy launch and ULA's 143rd mission. Built in Decatur, Alabama, the Delta IV Heavy is the largest and most powerful configuration in the ULA fleet. It's comprised of 3 common booster cores, each powered by Aerojet Rocketdyne RS-68A engines, and a Delta cryogenic second stage powered by an Aerojet Rocketdyne RL-10B2 engine. The satellite is protected during ascent by a 5-meter diameter payload fairing. Events leading to launch began on February 16th, when the 3 Delta boosters were lifted into their vertical position here at Slick 6. Then, on March 31st, the NROL-82 spacecraft, encapsulated inside the payload fairing, was transported to the Mobile Service Tower at Space Launch Complex 6 and mated to the Delta IV rocket. On Saturday, the Mobile Assembly Shelter, or MAS, was moved to its launch position. The MAS protects the Delta IV rocket from the wind and fog, so common to its location here on California's Pacific coast. At approximately 5 a.m. this morning, final preparations began at Space Launch Complex 6. Using 40 hydraulic cylinders at pressures nearing 3,500 psi, the MST was raised 8 inches and rolled back, revealing the Delta IV launch vehicle. At 100 feet by 100 feet by 300 feet, the MST is as tall as a football field is long, as wide as the length of a basketball court, and weighs about 10 million pounds. Using a carriage transporter system traveling at about a quarter mile per hour, it takes about 25 minutes to roll the MST to its launch position, 300 feet east of the rocket. The Delta IV Heavy stands 233 feet tall, or about 23 stories, and weighs about 1.6 million pounds fully fueled. The 3 Delta IV RS-68A main engines produce more than 2 million pounds of thrust at liftoff.
Roger. Gas Helsing. Go. Establish scan pattern 140. Roger. VSE, Elsie.
VSE.
For step 1180, verify base bending moment instrumentation is active and data is valid.
DBM is fully mission capable and recommend placard 6 alpha.
Roger. LOLC, net 1.
Here's the
I'll be utilizing placard 6 alpha.
Copy 6 alpha.
Today's launch is for the National Reconnaissance Office, or NRO. This is ULA's 31st launch for the NRO and 9th use of the Delta IV Heavy for the NRO. The NRO is a joint organization engaged in the research and development, acquisition, launch, and operation of innovative overhead reconnaissance systems necessary to meet the needs of the intelligence community and the Department of Defense. The NRO is recognized for its transformational intelligence collection systems that are used to develop highly accurate military targeting data, support international peacekeeping and humanitarian relief operations, and to assess the impact of natural disasters. The NRO provided the artwork we see on today's payload fairing. The details on today's artwork were inspired by a World War II fighter pilot who was awarded the Medal of Honor, a Navy Cross, and Purple Heart for heroism and dedication, and who had ace fighter pilot skills. This patriot was Gregory Boyington, known to many as Pappy. This logo was designed to commemorate the many heroic acts and sacrifices that have been made to protect America. The artwork features an eagle, symbolizing freedom, wearing traditional World War II flight gear. Behind the eagle is an F-4U Corsair, the aircraft that Pappy Boyington flew while in the Marine Corps. Additionally, we have the Latin phrase Tacitae Libertatis Custodumque, which translates to Silent Guardians of Freedom. Below the mission artwork, there is an additional patch recognizing the NRO's 60th anniversary this year. NROL-82 is ULA's 90th national security mission. Gary Wentz, Vice President of Government and Commercial Programs, talks about the significance of these missions.
We're really honored to be here today launching our 90th mission for our national security defense customer as we begin the celebration of the National Reconnaissance Office's 60th anniversary. National security satellites range everything from GPS to intelligence sources that our decision makers use to direct and focus our warfighters in defending our country. A good example of a national security space satellite would be something like a GPS system. It was previously used to locate warfighters in their domain and direct them in an area of a target. And since then, that capability has evolved and being used by citizens across the world. Launching these critical payloads for our national security defense customer is extremely important. There's a lot of challenges. You have to have a team that's focused with a national security background and have been cleared. You have multiple payloads that are coming together with unique requirements to test and check out before launch. We focus on vertical integration to give that spacecraft a similar environment on the ground as it'll see during ascent and headed to orbit. And then we actually deploy them at different locations because they serve different functions. We're really looking forward to starting with our new launch vehicle, the Vulcan Centaur, and actually be able to start integrating some of these critical payloads on that platform and launching here in the near future.
On-time verification.
Roger.
OSM, verify the whole fire switch is in the proceed position.
Today's flight is dedicated to frontline workers who have been vital to the fight against COVID-19. This mission is also in memory of two NRO teammates. A few moments ago, Mission Director Colonel Chad Davis remembered these friends and colleagues, Lisa Wilson and Ross Kobayashi. Let's listen in.
Today's launch is dedicated to the memory of past NRO teammates, notably including Lisa Wilson, engineer, friend, wife, mother and grandmother, who for 32 years provided unbounded support and technical direction for critical space lift missions, resulting in precise orbital insertion of satellite vehicles. Lisa's achievements are to be remembered as an example of service of the freedoms we stand for. Go for flight. And Ross Kobayashi, mentor, friend, husband and father, who for 25 years had been part of the OSL mission assurance team, responsible for the assessment of launch vehicle risks and the success of over 50 national launches across the Titan, Atlas, and Delta launch systems. Ross served as the technical chair for 28 NRO launches, leading the efforts to safely shepherd the payloads to orbit, culminating with the launch of NROL-81 from Slick 6. Fight on forever, Ross. MD out.
This is Delta Mission Control at T-minus 4 minutes and holding. We remain in the planned built-in hold as preparations for launch continue. In a few moments, launch conductor Scott Barney will poll the launch team for the final go to pick up the count. 27 engineers and managers are polled for system status and readiness to proceed. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Western Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Scott Barney performs the final polling of the launch team.
Status check to proceed with terminal count. First stage systems, propulsion. Go. Hydraulics. Go. LOX.
Go.
LH2.
Go.
Second stage system, LOX.
Go.
LH2.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
COM.
Go.
GCQ.
Go.
Operations support.
Go.
Pneumatics.
Go.
Umbilicals.
Go.
HAZGAS.
Go.
ECS.
Go.
Red line monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count.
L minus 6 minutes.
ALC Verify T0 is set for 20:47:00 Zulu.
Verified.
MEQ, establish swing arm lock pins pull.
Active.
Polling is complete and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now. At T-minus 4 minutes and counting, we will enter the terminal count and begin securing the second stage liquid oxygen tank. At T-minus 3 minutes and 32 seconds, CBC liquid hydrogen and liquid oxygen tank securing is started, including closing the propellant fill and drain valves. Also, at T-minus 3 minutes and 32 seconds, vehicle transfer from ground facility power to its own internal battery power will be complete. At T-minus 3 minutes, the vehicle ordnance system will be armed and the CBC liquid oxygen and liquid hydrogen propellant tanks are verified to be at flight pressure and flight level. At 2 minutes prior to liftoff, the team will verify that the hydraulic system is pressurized and confirm CBC, DCSS, and FTS battery voltages. At T-minus 1 minute and 20 seconds, the team will begin securing the second stage liquid hydrogen tank. At T-minus 60 seconds, Western range readiness is verified. At T-minus 50 seconds, the DCSS liquid hydrogen tank is secured at flight level. At T-minus 15 seconds, the launch table HBOs are ignited at the base of the vehicle to burn off excess hydrogen. At T-minus 7 seconds, the starboard CBC engine is ignited. At T-minus 5 seconds, the port and center CBC engines are ignited. Liftoff will occur at T0. This is Delta Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
T-minus 4 minutes and counting. 3:55.
Ground pyros enabled.
The countdown clock has resumed. We've entered the terminal count and are go for launch at 1:47 p.m. Pacific Time.
Second stage lock secure at flight level. T-minus 3 minutes, 7 seconds. $2:49.
FTS internal.
CBC locks at flight pressure and flight level.
CBC LH2 at flight pressure and flight level.
Hydraulic pressure at 4,000.
2 minutes, 1:59.
Vehicle internal.
1:55.
Launch sequencer start.
$1:40.
FCS launch enabled.
1:37.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and Western range are go for launch.
1:20.
Supposed to use arms.
FCS count started.
T-minus 1 minute.
Engine set box go.
Rock, report range status.
Rock,
Range is green.
50 seconds.
Second stage LH2, secure at flight level.
30 seconds.
Status.
T-minus
Go
30
Delta.
seconds.
Go NROL-82.
Fifteen seconds.
Roll for ignition.
10, 9.
T-minus 10, 9, 8, 7, 6, 5, 4, 2, 1, and liftoff of the United Launch Alliance Delta IV Heavy rocket carrying the NROL-82 mission for the National Reconnaissance Office.
You go on the pitch over maneuver? Parameters look good on all three cores. Core booster is now throttling down to the partial thrust level. Partial thrust achieved.
You are hearing the voice of Rob Kesselman providing launch vehicle ascent data.
Now, 50 seconds into flight, vehicle is 3 miles in altitude, 5 miles downrange distance, traveling at 970 miles per hour. All vehicle systems look good at this time. Now at T plus 80 seconds, vehicle is now passing through max Q, maximum dynamic pressure. Mach 1, vehicle is now supersonic. All three RS-68 looks healthy at this time. Vehicle systems continue to be healthy. The second stage reaction control system pressurization valve has now opened. Now 125 seconds into flight, Delta is now 18 miles in altitude, 9 miles downrange distance, traveling at 1,800 miles per hour. Delta has now gone to closed loop guidance. Vehicle body rates are nominal. Three minutes remain in the booster phase of flight. Delta IV rocket now weighs just 1/2 of what it did at liftoff, burning propellant at a rate of almost 5,000 pounds per second. One minute until port and starboard booster engine cutoff. Vehicle systems look healthy at this time. The attitude control system, the autopilot has controlled all vehicle body rates to near zero. Approximately 30 seconds remaining now until the port and starboard booster engines cut off. Strap-on boosters are now throttling down to the partial thrust level. Strap-on booster cutoff and separation of the strap-on boosters. Core booster is now throttling back up. Core booster is operating as expected at the 100% throttle level. The upper stage lock system has now begun the boost phase chill down sequence to begin thermal conditioning of the RL-10 engine. 1 minute remaining in the booster phase of flight. Upper stage fuel system has begun the boost phase chill down sequence. Booster performance continues to look good at this time. Vehicle body rates continue to be near zero as expected. Core booster is now throttling down. And we have BECO, first stage main engine cutoff. We have stage separation. NEDS deployment has begun. Pre-start on the RL-10. We have ignition on the RL-10, that's one. We have indication of successful payload fairing jettison.
This year, the National Reconnaissance Office celebrates its 60th anniversary. From its inception in 1961, the NRO has used its incredible intelligence collection capabilities to meet the nation's challenges. Let's take a look back at the agency that has pushed the envelope of U.S. space-based intelligence collection with courage and ingenuity.
This year, the National Reconnaissance Office celebrates 60 years since its founding in September of 1961. Thanks to our heritage, the NRO today has an unrivaled constellation of advanced overhead reconnaissance systems that help protect our nation 24 hours a day, 365 days a year. As part of our anniversary celebration, the NRO's Center for the Study of National Reconnaissance has put together a year-long program highlighting key events and innovations that shaped the NRO's past, present, and future. In a moment, I'll share some of those historic milestones with you, but be sure to follow us on social media for more 60th anniversary content. When we think about satellites today and the near real-time digital data that NRO overhead systems provide, it's hard to believe that the first overhead reconnaissance efforts relied on camera film and balloons. One of the earliest film return reconnaissance efforts was called Genetrix. In 1956, the U.S. Air Force began launching high-altitude balloons from Europe and Turkey that would sail across Eastern Europe and the Soviet Union, taking pictures along the way as they floated by. Then, when they got out over the Pacific, the Air Force retrieved the balloons from midair in C-119 aircraft. This recovery experience was invaluable a few years later for the Corona program. Corona took aerial recovery a step further because the film was ejected from a satellite instead of floating along in a balloon. These early film vehicle captures were so essential to the field of reconnaissance that we've placed examples in the NRO headquarters lobby. Each parachute represents one of the critical innovations that brought the NRO from 1961 up to today. Another enduring legacy is our history as both a member of the intelligence community and the Department of Defense. In the late 1950s, all three military services, as well as the CIA, were involved in trying to launch satellites, each for their own unique purposes. By the time President Kennedy took office in 1961, it was clear that all of these various efforts would be more effective and efficient if they were managed within one single organization to control budgets and facilitate coordination. So on September 6, 1961, CIA and the DoD signed an agreement to form the jointly managed National Reconnaissance Office to run the National Reconnaissance Program. As a result of our unique position, NRO for 6 decades has worked with our DoD and IC partners to inject advanced capabilities into our operations to deliver critical intelligence to policymakers and warfighters worldwide. We work with our mission partners, including NGA, NSA, CIA, DIA, Space Command, Space Force, to provide global situational awareness to government and civilian agencies. Today's NROL-82 mission launch represents not just years of planning and collaboration for the specific mission, but a 6-decade legacy of innovation and reconnaissance.
Rock, report range status.
Range green.
Launch enabled.
We have main engine ignition. 2, 1, and liftoff. Liftoff of the United Launch Alliance Delta IV Heavy rocket.
When the nation needs eyes and ears where no other collectors can reach, it turns to the NRO.
This is Delta Mission Control at T plus 10 minutes. Rob Kesselman just confirmed the successful completion of the early phase of today's flight, and all systems continue to operate nominally. I'd like to thank Rob for his support of today's show. For more information about this mission, please follow us on Facebook and on Twitter, or our blog at ulalaunch.com. We'll leave you now with another look at the liftoff of the Delta IV Heavy rocket carrying NROL-82 for the National Reconnaissance Office. I'm Caroline Kirk, and on behalf of the entire launch team, thank you for joining us and have a great day. 8, 7, 6, 5, 4, 3, 2, 1, and liftoff of the United Launch Alliance Delta IV Heavy rocket carrying the NROL-82 mission for the National Reconnaissance Office.
You go on the pitch over maneuver. The parameters look good on all 3 cores.